Hello. Now we will study the isothermal process. So first of all, let's explain what is isothermal process, what kind of equation it has, and what kind of graph we can make out of it. So as you already know, the ideal gas equation is PV is nRT. So if the system is closed, generally the value of n is constant. So in this equation, you see there are three variables. One is pressure, second is volume, and third is temperature. And with three variables, we don't proceed generally. So when we define the isothermal process, we put one more condition onto this ideal gas equation, and the condition in case of isothermal process is the temperature in that process remain constant. So this becomes the equation to represent the isothermal process. Temperature constant. See, and temperature constant, so if the temperature is remaining constant, the P and remaining other two variables, the P and V, there will be one more condition onto them. So if I put this value here, meaning if n is a constant, R is a constant obviously, and if T is also constant, this equation can convert itself into PV is equals to constant. So you see, both of these equations represent isothermal process. Meaning whether the examiner is giving you temperature constant or is giving you PV is equals to constant, it leads to isothermal process. Okay, there will be multiple ways to explain this equation. So this is a analytical representation, meaning in terms of equation we can represent this. Now one more representation we need, and sometimes we solve the equation using that representation. That's a graphical method. So let's represent this equation in terms of graph. And when we talk about graph, we'll make the graph using these three variables. So the first graph we want to make is between pressure and temperature. So I'm putting pressure onto the y-axis and the temperature onto the x-axis. So P and T graph, if we see in this equation, if you see, this is the thing. T is a constant. So if you plot this isothermal process onto the PT graph, it will show you the straight line. And that straight line will be parallel to the pressure axis. And this straight line, if you extend that straight line, this will cut the temperature axis at some temperature T0, which is a constant obviously. So this straight line represents the isothermal process in case of PT graph. Let's go for PV graph. Let's represent the PV graph. So this time I'm representing VT graph. So I'm representing the volume axis onto the y-axis and the temperature onto the x-axis. So one more time I'll proceed with this. In this equation also, in this case also, it will be a straight line which will tends to cut the temperature axis onto the temperature T0. So this is your isothermal graph in case of VT curve. Now let's go for the third one, which is the PV, which generally we use. Majority of time we proceed with PV. So if I'm putting the pressure onto the y-axis and volume onto the x-axis, so this is the equation we have to proceed. And if you see this equation represents xy is equals to constant. It's a parabolic equation. So if I represent this equation onto this PV graph, I'll get that kind of graph. So this graph will represent isothermal process. And you see, in this graph, if you want to calculate some things, like the very first thing we want to do will be to calculate the slope. So at any point, I'm defining the point as PV. If I want to calculate the slope will give us this tan theta at different points, and the slope will be equals to dP by dV. That will be equals to tan theta. To get dP by dV, this is the equation. So if I differentiate this equation, on differentiating PV is equals to constant, I'll be getting P dV plus V dP is 0. I'm differentiating these two are variable. On the right hand side, everything is a constant. So one by one I differentiate. So first I differentiate V, keeping P constant, then I differentiate P, keeping V constant. And if you see here, dP over dV value will be equals to minus of P by V. So minus of P by V value will give you the slope at any point. You just have to put the pressure and volume at that point. Okay. So by calculating the slope, we can calculate some other things also. So this is the representation. This is the graph. This is the analytical representation of the isothermal process, and these three are the graphical representation. Okay, thank you.